This video will cover section 5.4, the fundamental theorem of calculus, from our class. And so we're going to start with just reviewing what we know. We already know that the integral is we could call it the area function, right? What we see here. And of course, let the function be a continuous function and that could be integrated. And so with left point A, so that will be here, our lower limit. And then we have x here, just to generalize. But what we're saying here is that x is greater than a. So it's like one of those basic little easy integrals, right? The ones that we don't have to flip the sign or anything. So with using that, which we've been doing already, you find the net area. So remember, difference with net area is that it could be positive, negative, and also zero, right? So difference with like the typical geometry area that we know. So we're gonna do this easy problems, and we have a graph, and it is shown there, and with the areas of various regions marked. And so we're gonna have two area functions, okay? They're not the same, so this is one of them. And then this is the other one. So the way we're gonna tell them apart is with the uppercase letter, right? A and F. And if they're uppercase, then we'll be referring to the integral. So we have the two, and then note the different left endpoints, right? So function uppercase A goes from -1 to x. So from -1 to whatever the x value is, okay? And so that x value is gonna come from here. All right? So the input that we have here for the area. So for example, if I ask you what is the area, uppercase A of 3, we will consider the integral of that function from -1 to 3. All right? All clear? Okay. So then that will go to here. So what will be the answer for that one? And you actually have it written there. -27. It's very good. Negative because it is below the x-axis. Yes, below the x-axis. Very good. Now let's find the other one, and that will be for function f. And so that one is going to go from, not function f, I'm sorry, the area. So uppercase F, and so we're going to go from 3 to x, and that particular value of x is going to be the same. So it's like we're doing the integral from 3 to 3. Do you guys remember what that will be? 0. Very good. Let's try this. So I actually have seen some questions like that on previous AP exams, and yeah, it does sound, well, look a little confusing or intimidating if you don't know like the set limits, but it might just be like it looks tough at first, but if you read the rest, like it might not be as tough, right? So you just substitute whatever the numbers in parentheses for your endpoint, your right endpoint actually. So now the next one, we have A of 5. So we're going to calculate the area from here to here. So now that is going to be the area that we calculated from here to here, which was -27. And then the area from here to here is positive, right? It's above the x-axis, and that's equal to 3. So that will be -24. Now let's calculate f of 5. And so for that one, we're going to go from 3, because that's how the integral is defined. The lower limit is 3. So the area from here all the way to 5. Isn't it this one we did? Oh, no, it was 3. Okay, so from 3 to 5, and that would be positive 3. Now we move on to the last one. Where should I give it a try for that one? So for a of 9, that's the one that you start at -1, right? Because that's how it's defined here. Lower limit, -1. So we're going to have -27 from here to here. And we're actually going to go all the way here. So this will be +3 and then -35. Do we have a number for that already? -54. Now let's try.
Sorry, 59. Sorry, -59.
Okay. 59. And so next one, f of 9. So again, we're not going to start at -1 anymore. Where do we start? What is our lower limit for this integral? 3. So from here all the way to 9, right? So we have +3, and then -35. And so that will give us -32. Pretty easy, right? Yes, yes.
I don't understand.
Are you serious?
Yeah.
Are
I
you
don't
joking?
understand the A and the F. Like,
Oh, you're serious? Okay, I thought you were being sarcastic. Okay, I'm sorry. All right, okay, so think of them as like just little functions, right? So they are functions in reality. And so like if you had something like f of x, I don't know, like natural log of x plus 3, right? And then if I ask you, what is f of, let's say, an easy one, I'm going to pick an easy one. -2, f of -2. So if I pick f of -2, what do? Alejandro?
you put it in?
Okay, so it will be -2 plus 3, right? So now here, this is the ln of 3 minus 2, which is 1, and the natural log of 1 is 0. So that's just with like a function, logarithmic function. Now here, what they're doing with the function is an integral itself, right? So then if I ask you, what is, well, let's redo the first one. So it was, what is the area, so this one here, uppercase A of 3, okay? And so I'm going to take the integral, the same one, and I'm going to set my limits from -1, because that's set there,
Okay.
constant, and then my upper limit, since it says x, then just like you told me, you substitute your x there, right? So I'm going to substitute my upper limit to be 3.
I understand.
Okay, and then here, of course, we do that, but we don't need to worry about knowing what the function is because we have the work, right? So the x part is just for the input of the area function, and it will also denote the ending point of the area that you want to take, or the right endpoint, I should say. Yeah, is that right? Okay. Yes. So, yeah, don't be surprised if you see those pictures. Now, you could have something that has an integral, and then your x goes here, and then here you might have, like, the upper limit. Okay, so that, it's okay if that happens. All right, so let's move on to the next one, if you guys don't have any more questions. Alyssa, no questions? Good. Okay, so area of a trapezoid. Now, for this one, we consider the trapezoid bounded. Ooh, I like this. Bounded, because this is a little intro to what we're going to do with like calculating the area between functions, and then the volumes. So bounded by the line f of t equals 2t plus 3. So this is our line. And then the t-axis. Now, you guys notice instead of using x, we're using t, right? Okay. T. So, when we say bounded by the t-axis, and you guys are going to see this a lot on those problems that I'm talking about, that we have to do next week for sure. So that's the t-axis, right? So then you look at the area from all of that, and of course this could be also included, right? And this included. But they're setting our limits to go from 2, t equals 2, to t equals x. Now here, t is the independent variable, okay? And then x is kind of like we're using like an extra variable just so that we could change them, like to go from 2 to 2, from 2 to 3, from 2 to 4, from 2 to 5. All right? Is that clear? Yes? But so then if we go from We start at 2 because that is our lower limit. Right here. So it's still bounded there. And so now you guys can see that we're going to have a trapezoid, right? And now for x greater or equal to 2. So now if we want to evaluate this one, we take the integral and we will go from 2 to 2 for that particular function. So that, what would that be? 2. Very good. Now, if we want to evaluate the next one, which is from 2 to 5, from 2 to 5 for that particular function, and then we have to put dt because our independent is t. So then this one, we will pretend for a minute that this x is equal to 5, right? So then how can we get our measurements? So let's see. Let's review area of trapezoid quickly. So you take b1 plus b2 times height and then divide by 2, right? So turn your head like 90 degrees, counterclockwise. You can see this will be b1 and this is going to be b2. Yeah, the bases will always be parallel to each other. That's how you know which one's the base. So then, for this one here, for base 1, the way we're going to find it is going to be the y value for x equals t equals 2. I know. So we have the function here. Oh, where is it? Here, right? So let's find f of 2. So that would be 2 times 2 plus 3. Yeah, is it clear? I'm getting them from here, from this function. So we do that. 4 plus 3, so we get 7. So that number right there is going to be 7. Now let's find the height or the length of b sub 2. And so that's going to be the function value, the f of t at 5. So 2 times 5 plus 3. So that would be 10 plus 3, which is 13. Okay. Now we have that. Do we know what the height will be? If you turn your head 90 degrees to the left, it's 3. So it will be from here to here, right? And I heard 3 from someone. So if we say 5 minus 2, we will get 3. So then the height will be equal to 3. And so that's what we need to find this area. So I can go back this here and say, so the first base was 7 plus the second base 13. The height was 3, and then we divide by 2. And so that would be 20 times 3 is 60 times, divided by 2 is 30. Yes? Is it 30? Do we agree? Okay. All right. Now find the graph. Find and graph the area function. Okay. So what we're going to do for all x greater or equal to 2. So let's see. Consider that you just have your line again, right? So from 3. So the equation was actually 2t plus 3, correct? And we want to calculate the area for all numbers greater than 2. 1, 2. Okay. And so at 2, so let's make a table. So this will be the area at 2, and that we found out since they want us to make a function that starts at 2, so this will be our starting point. And so we found the area at 2 was 0, right? Yes? Okay. And then, which other one did we do? Just 5?
Oh, yeah. That might be hard.
So at 5, what was it? I forgot. 30? Okay. So let's find out what it will be at 3, and then at 4. And do they want us to stop anywhere? No, they just want the general form. So I think we need more to find a pattern, but we could use a little bit of thinking. So for example, if we were thinking in terms of a derivative, right? And I tell you your original function is power 3. So then your derivative is going to be of what power? 2. And what if I ask you for the integral of your function? Is it going to be of power 2 what? 4. Exactly. And this should be like 3, yeah, right? And then the integral of this will be n divided by 4. Okay. So you guys see the power goes by 1 up or 1 down, right? If you're dividing or integrating, at least for polynomials. So now we have a line that is of what degree? What is the exponent of t? 1. We have polynomial of degree 1. Yes, lines are also included in polynomials. So if we were to take the integral of that, what degree would it be? Square or 2. Yes, very good. So let's see, if we wanted to calculate the area at 3, we would use the same thing that we did here, but the difference will be this value right here, right? The 13. And how do we find that 13? You guys remember? We solved this f of 5, right? So we substituted that. So then what we're going to do is find f of 3. So that will be 2 times 3, 6 plus 3, 9. And then let's just go ahead and find f of 4, which will be 2 times 4, 8 plus 3, 11. Yeah? Yes. No. Yeah?
Yes.
Okay, okay. All right. And then, so we want to calculate the area at 3. It would be something like 7 plus 9 times divided by 2. And now, what is the distance in between? So this is what we call heights, right? Of a trapezoid. So what would be the height here?
Minus x. Or x
3 minus, so 3 minus 2 or x minus, yeah. So that will be 1, right? So 7 plus 9 is 16 divided by 2, 8. So now we have here at 3, a of 3 will be 8. And actually, I think we could find it with 3 points is enough to find it. Yeah? Let's find one more. So f of 4 is 11. So if I want to find the area of 4, it's going to be 7 plus 11 divided by 2. And then the distance between 4 and 2, which will be our new height of our trapezius. I can't even think of the name. So this will be 2, right? So it looks like an exponent, but it's not. So 7 plus 11 is 18. So a of 4 is going to be 18. Now see if you can think of the quadratic equation.